Hello everyone. In today's lecture, we'll discuss about homework questions of lecture number 3. Class 12th, chapter probability, lecture number 3, homework solution. Here is the first question, which says a box of oranges is inspected by examining 3 randomly selected oranges drawn without replacement. That means how a box is to be inspected just by selecting 3 oranges out of the total oranges but without replacement. Without replacement means we are picking out one, taking out one orange, keeping it aside, and then without placing it back in the box, right? Keep that aside, and then the second orange is to be picked from the box. And similarly for the third one. If all the 3 oranges are good, the box is approved for sale. Otherwise, reject the box. Right? If you are picking one by one 3 oranges from the box and all the 3 are good, the box will be approved for sale. Otherwise, it would be rejected. Now we have to find the probability that a box containing 15 total oranges, out of which 12 are good oranges and 3 are bad oranges, the box is approved for sale. So let A be the event that box is approved for sale. Now we have to find the probability of P of A, event A. Now the first orange that you are selecting is good, right? If the box is approved for sale, we know that all the 3 oranges have been good. Probability of the first orange to be good is 12 by 15 because number of good oranges is 12. Total is 15. Now out of 12, you are taking out one and keeping it aside. So number of good oranges left is now 11. Divided by 14 now because one has been taken out. So total number of oranges left also is 14. So this is the probability for second orange. For the third orange, instead of 11, now we have 10 good oranges left. 10 divided by total number now will be 13. And we can solve it. 2 sevens are, 2 fives are, 3 fours are, 3 fives are. Just cancel the things. 5 and 5. So 11 into 4 is 44. Divided by 13 into 7 is 91. The probability of the box being approved for sale is 44 by 91. This is how you are going to find the probabilities, right? So you see, without replacement is making a difference in the probability of taking out the good orange out of the box. Now we shall move to the next question. The next question is here, question number 7. In question number 7, we have been given that events A and B are such that P of A is given and P of A union B is given. P of B is also given as P. We have to find the value of P. The first one is mutually exclusive if A and B are mutually exclusive. We know if two events are mutually exclusive, the probability of their intersection would be 0 because mutually exclusive means they are disjoint sets. There is nothing common in them. Now, we know probability of A union B is probability of A plus probability of B minus probability of A intersection B. A intersection B is 0 for us. A union B is given as 3 by 5. A is given as 1 by 2. B is given as P. Solving it, taking the LCM, we get the probability of B, which is represented by P as 1 by 10. In the second part, they are saying that they are independent. If they are independent, A intersection B would be probability of A into probability of B. This is the condition for independent events. Now, putting in the same formula, A union B, is equal to P of A plus P of B minus, instead of PA intersection B, we can write P of A into P of B. A union B is 3 by 5. P of A is 1 by 2. P of B is P minus 1 by 2 into P. So solving it now, this is P minus half of P, which is half of P itself. And here it is 1 by 10 when you solve. So P will be 1 by 5 in the second case. So value of P is different if we change the condition of the events to be mutually exclusive or independent. So I hope this is also clear. Let's move to the next question. Here is question number 9. In question number 9, they are asking A and B are two events. P of A is given as 1 by 4. P of B is given as 1 by 2. A intersection B is given as 1 by 8. We have to find the probability of not A, not B, which is to be represented by not A. For and we use intersection not B. This can also be represented as A union B whole complement. You have done this in sets. This will be written as 1 minus probability of A union B. As you know, probability of not A or complement of A is given as 1 minus probability of A. Same formula I am using for A union B complement. Now, let us first find A union B. A union B will be P of A plus P of B minus P of A intersection B. Okay, now placing the values in the formula, P of A is 1 by 4, P of B is 1 by 2, A intersection B is 1 by 8. Taking out the LCM as 8, 4 2s are 8, 2 4s are 8, minus 1. So it is 4 plus 2, 6, minus 1, 5 by 8. So we will place this value here in this equation. So we will get it as 1 minus 5 by 8. Taking the LCM as 8, we get 8 minus 5, which is 3 by 8. So probability of not A and not B in this question is 3 by 8. Quite easy to do. Let us move to the next question now. Here is question number 12. A die is tossed thrice. 3 times you are tossing the die. Find the probability of getting an odd number at least 1. Probability of getting the odd number is, out of 6, 3 are odd. 1 out of these 6, the odd are 1, 3 and 5. 3 out of 6. So the probability is 1 by 2. Fine. Now we are tossing it 3 times. We have to find the probability of getting an odd number. That means you can get it once, you can get it 2 times, you can get odd number all the 3 times. Right. So instead of making all the certain cases that it came in the first row, it came in the second row, or in the third row, or in 2 throws, or in 3 throws, I can just do one thing. If I find probability of not getting in the first case, not getting odd in the second case, not getting in the third case, if I calculate this, so if probability of getting it is this, getting the odd number is 1 by 2, not getting is also 1 by 2. So 1 by 2 into 1 by 2 into 1 by 2, that is 1 by 8. Right? Now I have to find probability of at least once you get, right? So if I say probability of at least once getting an odd number, at least once, right, you get the odd number. The probability, if I subtract it from 1, that all the 3 times we do not get any odd number. I'll get the probability of getting odd numbers at least once. That means excluding one case, all the cases are included here, right? And which is the one case that we have to exclude? That we don't get odd number in any of the toss. Clear? We can do it by another method also, in which we have to find out like make the cases. Case one would be that you get one head, that can be in first throw, that you can get in second throw, that you can get in third throw. Case second will be you get odd two times, that can be in the first second throw, second third throw, or first and third throw. The next case would be all the three times, all the three tosses you get odd numbers. That will be first also, second also, third also. So making these cases and adding them, you're going to get 7 by 8 itself. But that's a quite lengthy method. So just we can subtract one case in which we do not get odd any of the throw. In any of the throw, we can get the answer for it. Let us move to the next question. Question number 13. In question number 13, they are saying we have two balls are drawn with replacement. That means you pick out one, then place it back in the box. How many? 10 black balls we have. 10 black. Okay. And 8 red balls we have. So they are saying in the first case, both the balls are red. So red will be taken from this. So first of all, 8 upon total number of balls is 18. 8 upon 18. You can select 2 4s are 2 9s are 4 by 9. But this is only the probability of one ball. We have to find out probability that both the balls are red. Now after taking out one ball, the second ball is taken out with replacement. That means the first one is placed back in the box. Then again we have 8 red balls. Solving it, you get 16 by 81. In the second part, they are saying first ball is black, second is red. So I am writing it as first ball black, second as red. Black, the probability will be 10 by 18. For the second one, it will be 8 by 18. There will be no deduction in the number of balls because we are doing it with replacement. So solving it, 2 5s are 2 9s are 2 4s are 8, 2 9s are 80. 5 4s are 20, 20 by 81. In the third part, one of them is black and other is red. Now we do not know which one is black, which one is red. So we are going to consider both the case that the first is black, second is red, or the first is red, second is black, right? So first, probability of black into red plus probability of red into probability of black. We have already calculated this. See here, it is 20 by 81. 20 by 81 plus 20 by 81. That gives us 40 by 81. So this is the answer for the third part. I hope this is clear. Let us move to the last homework discussion problem. Probability of solving specific problem independently by P of A. If A is solving the problem, the probability is half. If B is solving the problem, the probability is 1 by 3. Now, if they both try to solve the problem, in the first case, we have to find that the problem is solved. So, if the problem is solved, that means what? Either A has solved or B did not solve. Or what case we can have? B did not solve, right? A did not solve and B is solved. B is solving the problem, right? Or they both solve the problem. All these cases can be taken. The problem is getting solved even if one solved the problem, right? So one of them can solve either A or B or both of them. P of A, you know it is 1 by 2. P of B, how not B? How will you calculate P of not B? 1 minus 1 by 3, that is 2 by 3. So 2 by 3 plus not A, how will you calculate? Subtracting it from 1. You subtract, you get half only. into P of B is 1 by 3 plus 1 by 2 into 1 by 3. Solve it. 1 by 3 plus 1 by 6 plus 1 by 6. Take the LCM as 6. 2 plus 1 plus 1. 4 by 6, that is 2 by 3. So if the problem is solved, the answer for that would be 2 by 3. Let us move to the next one. The second part says, in the second part, as you can see, they are saying exactly one of them solves the problem. If one of them is solving the problem, that means either A is solving, B is not solving, or A is not solving, B is solving. That means exactly one of them is solving the problem. P of A is 1 by 2, not B as we calculated, you see, not B. We calculated it as 2 by 3. 2 by 3 plus not A is 1 by 2 into 1 by 3. Just solving this 1 by 3 plus 1 by 6, taking the LCM as 6, you get the probability as 1 by 2 for the second part. So that's all for today. Now in the next lecture, we'll discuss about the total probability theorem and the Bayes theorem. Every time a question of 6 marks comes in CBSE from that. It used to come every time. So that's the most important concept of probability Bayes theorem. So hope you read that carefully, learn the theorem carefully. That's all for today.